In your business, unless an engine runs efficiently and for long periods of time without need for repair or replacement, that engine becomes an unnecessary expense and a drain on profits. If you have come to believe that repetitious engine downtime is to be expected and tolerated, you'll be pleased to know there is a way to greatly increase length of service between teardowns and repairs. By establishing an ongoing preventative maintenance schedule for every engine you own, periodic preventative maintenance can add years of productive service to the engines you depend on for a profitable income. Instead of routinely disposing of engines after only a few hundred hours of work, you can gain 3 to 4 times more useful life at very little cost. With periodic preventative maintenance, you'll increase your return on investment in engines at least 300%. Can you afford not to? All that is required is a willingness to adhere to a realistic schedule of routine engine checks and a few extra pennies needed for regular oil and air filter changes. Checks that take far less time than the wasted struggling with worn-out engines. The entire systematic procedure is quick and simple, as you will see. The basic requirements for efficient engine operation are regularly changed and sufficient amounts of oil, fresh, clean fuel, clean air, and lots of it, adequate cooling, and periodic removal of the combustion chamber deposits. Therefore, the systematic preventative maintenance program is structured to assure you're supplying the engine what it requires to deliver the long life efficiency you have a right to expect. Briggs & Stratton engines are designed and built for long service life and efficient power delivery. However, as with all engines, the user must do his part too. Long service life and efficient power delivery, two important but not identical terms. For maximum productivity, both are required. Preventative maintenance not only adds years to engine life, it assures top power delivery throughout an engine's long life. How good are Briggs & Stratton engines? Every Briggs & Stratton engine is endurance built and tested to run more than 1,000 hours. Engines are selected at random from our many assembly lines and put through an Indianapolis 500 type test, running 24 hours a day under load around the clock, stopping for only periodic maintenance. This 1,000-hour endurance test is the equivalent of driving your personal car around the world almost 3.5 times at 85 miles an hour. On a small engine running at 3,600 RPM, the piston and connecting rod change direction of travel 432,000 times an hour, almost 3.5 million times in an 8-hour day. Piston travel distance in 1 hour for the same engine would be 108,000 feet. That's the combined length of 360 football fields. In an 8-hour day, the piston would travel to a height alongside today's communication satellites. We only mention these figures so we can more fully impress upon you the importance of having a tried and proven preventative maintenance system, because without one, the engine is doomed for a short life cycle. Let's talk about fuel. We recommend the use of clean, fresh, lead-free gasoline. Leaded gasoline may be used if lead-free is not available. A minimum of 77 octane is recommended. The use of lead-free gasoline results in fewer combustion deposits and longer valve life. Our engines will operate satisfactorily on any gasoline intended for automotive use. Do not mix oil with gasoline on our 4-cycle engines. Further, it is important that you purchase gasoline in small quantities and not more than a 30-day supply at a time. Fresh gasoline minimizes gum deposits and also assures fuel with volatility tailored for the season. Many people do not realize that the blend of gasoline changes at least 4 times a year. This can have a more telling effect on the operation of your engine than the octane rating. In winter, the fuel is blended to make it more volatile for improved cold weather starting. In summer, the fuel is less volatile to prevent boiling and subsequent vapor lock. This blend changing is completely satisfactory for use in an automobile, for the fuel is used as it is purchased. It can be troublesome, however, for any equipment operator who keeps a supply of gasoline on hand and uses it infrequently. By the way, gasoline is subject to oxidation, or, in other words, it becomes stale. This results in deposits of fuel gum in the fuel system and carburetor, and commonly causes the intake valve to stick. What this means to you is the engine won't start, regardless of how many times you try. The ideal preventative procedure, of course, would be to buy gasoline by the tank full, as you do for an automobile. Ideal, perhaps, but not very practical. Assuming, then, you will keep fuel on hand for convenience sake, there are several rules you should know about to avoid trouble. First, do not carry a supply of fuel from one season over to the next. No more than a 30-day supply is desirable. Secondly, the use of a fuel additive, such as stable or an equivalent, will minimize the formation of fuel gum deposits during storage. Such an additive may be added to the gasoline into the fuel tank and the engine, or to the gasoline in the storage container. And thirdly, keep gasoline stored in a cool, ventilated place to hold oxidation to a minimum. For engines seeing a continuous daily work cycle, the use of lead-free gasoline is the preferred fuel. This is because its usage results in fewer combustion chamber deposits and longer valve life. Let's study the subject of combustion deposits further by asking this question. Which of the following servicing procedures does more to restore engine power and efficiency? A, replacing the breaker points. B, rebuilding and adjusting the carburetor. C, cleaning out combustion deposits. The correct answer is C. Cleaning out combustion deposits restores horsepower and efficiency by as much as 40%. This one simple servicing procedure is the single most important task you can perform. These are the deposits that will prevent any engine from performing to peak efficiency. Removing these deposits has a second benefit too. Removal minimizes the chance of these deposits lodging between the valve and seat, causing valve burning and a loss of compression. This graph shows the direct relationship between loss of horsepower and the accumulation of combustion deposits. From the instant an engine is first placed on the job and is run over a period of time, combustion deposits accumulate, and as these deposits continue to build up, available horsepower, engine efficiency, continues to further drop off. This phenomenon will persist and take even a greater toll on the engine as long as you allow this condition to go unchecked. Horsepower will continue to drop off until your equipment no longer performs well on the job. You find your equipment stalling, lacking power, performance. The job slows down. Combustion deposits building up around the valves act like dams. These dam-like deposits snuff out some of the available horsepower by restricting the incoming fuel-air mixture and restricting the escape of exhaust gases. Because constant speed and constant load applications, like pumps and generators, do not generally have a frequent start and stop work cycle, the rate at which these combustion deposits accumulate is greater on these applications than on engines seeing a frequent start and stop work cycle. This is because frequent start and stop work cycles produce fluctuations in engine temperatures, which tend to retard the buildup of deposits. Engineers call this phenomena thermal shock. Therefore, engines powering applications like pumps and generators will generally require more frequent removal of deposits, and these applications can least afford a loss of efficiency. As a routine maintenance procedure, power tune up your engines by removing these deposits monthly, or about 100 to 300 hours. Let's show you how you can remove these combustion deposits. First, disconnect the spark plug wire. Now, remove the blower housing and cylinder head bolts. Note the original bolt location so each bolt can be returned to its original position, for some head bolts are longer on certain engine models. Turn the crankshaft until the piston is at top dead center and both valves are closed. Using a putty knife or a wire brush, remove deposits from the cylinder head, top of the piston, and from the valve area. Be careful not to gouge any metal surfaces. Concentrate on removing the bulk of deposits. Some staining will remain. This is okay. Here's a service tip. Tough, stubborn carbon within the cylinder head can be first softened by immersing the head in a pail or pan of an ammonia-based household cleaner. Let it soak for about 15 minutes, then remove the deposits. Reuse the head gasket if it's in good condition. Replace the head and tighten each bolt until it is lightly seated. With an 8-inch handle wrench, use a staggered sequence to tighten all bolts about 1/8 turn. Run the engine for several minutes, then retighten the bolts. For a specific head bolt torque value, refer to the Briggs & Stratton Service and Repair Instructions Manual. Before completing our fuel discussion, let's look at the importance of inline fuel filters for engines equipped with flow-type carburetors. For a gravity-feed fuel system, the fuel tank above the carburetor, a 150-micron inline fuel filter is a good investment. Such a filter is available under either part number 298090 or 395018 from your local Briggs & Stratton service dealer. This filter will assure that only clean fuel passes to the carburetor. It prevents foreign particles measuring greater than 0.006 of an inch reaching the carburetor. 0.006 of an inch is the thickness of these 2 sheets of paper. Keeping foreign particles out of the carburetor just makes good sense. Besides, it reduces the chance of carburetor leakage problems. Every season, replace the fuel filter. Let's now comment about oil. We recommend the use of any high-quality detergent oil. Such oils are found in containers labeled with one or more of the following API, that is, American Petroleum Institute classifications: SF, SE, SD, or SC. No special additives need be used with recommended oils. Detergent oils tend to keep the engine cleaner by keeping byproducts of the combustion process in suspension, and when changing the oil, the byproducts drain with the oil. Let's take a closer look at these oil classifications. On an oil can, you will find any one or a combination of these letters: SA, SB, SC, SD, SE, or SF. These letters can also appear in conjunction with any one or a combination of these letters: CA, CB, CC, or CD. The S designation oils are for use in spark ignition engines, while the C designated oils are for compression ignition, diesel engines. As we indicated, you will want to use only these oils with the SC, SD, SE, or SF classifications in Briggs & Stratton engines. Often these classifications are also accompanied with a C oil designation. That's okay, just as long as the recommended S classification is also met. Oil viscosity is the relative thickness of the oil. The viscosity should be matched for the season of operation. Simply put, the higher the viscosity number, such as SAE 30, the thicker the oil, required protection at warm temperatures. The lower the number, such as SAE 10W, the thinner the oil, for cold weather running. The multi-viscosity oils, because of various additives, fit most requirements for both warm and cold weather operation. Neglecting this matching opens the door for a catastrophic failure. Use of a synthetic oil has an advantage for improved cold weather starting below 20 degrees Fahrenheit. Otherwise, using a synthetic oil at the warmer end of the temperature scale merely increases your equipment operating costs. When you check or fill the crankcase with oil, first wipe away any accumulation of grit around the oil fill opening. Keep grit from falling into the oil fill hole. On engines equipped with an extended oil fill tube and dipstick, fill to the full mark. When checking oil, screw the dipstick assembly firmly but slowly until the cap bottoms on the tube. Then remove the dipstick, checking the oil level. On engines equipped with the short oil fill plug, remove the plug, filling the crankcase to a point of overflowing. Always check the oil level or add oil with the engine on a level surface. Be careful not to overfill, and be sure the oil level is maintained. Check the oil level every time the engine is refueled, or at least daily, every 8 hours. Weekly, or every 50 hours, change the oil. Drain the oil while the engine is warm and refill. An engine allowed to run with an insufficient amount of lubrication will fail prematurely. Due to the absence of a sufficient amount of cooling oil, engine internal temperatures increase beyond what internal moving parts can withstand. Critical operating tolerances change because of the abnormally high temperature. As shown here, parts become discolored. Metal transfer or scoring occurs between crankshaft journals and their respective mating bearings. And as the result, the engine suddenly seizes. Parts break. Commonly, it's the connecting rod. An engine failing in this manner is normally beyond economical repair. Often, a short block or a replacement engine is selected to repower the equipment, an expense which merely increases your cost of running a business. Here are some common causes of parts discoloring and scoring. Obviously, you'll want to avoid these situations. An insufficient amount of oil, lubrication. Overfilling the crankcase with oil. Oil viscosity not matched to the season. Excessive oil consumption due to engine wear or loss of crankcase vacuum. Excessive operating angles. Leaking oil seals. Oil sump-cover gasket. It has been said that the life of any engine is only as good as its air cleaner and the regular preventative maintenance it receives. A typical small engine consumes about 10,000 gallons of air for every gallon of gasoline, entering at 25 miles per hour. Here, let's show you the area occupied by 10,000 gallons of air. It's a space measuring 12 feet by 12 feet by 8 feet high, the size of a small bedroom. A lot of air to be consumed with each gallon of fuel. This incoming air must be clean and free from airborne grit. Service the oil foam air cleaner every 25 hours. Under extremely dusty conditions, daily service may be required. Simply cleaning and re-oiling the oil foam cleaner as recommended can substantially increase engine life and performance. It is the oil in the foam, acting like flypaper, that traps and prevents damaging airborne grit from gaining entry into the engine. When servicing, first inspect the element for any damage, such as for tears, as shown here. If in doubt as to the element's true condition, replace it using only a factory original equipment air cleaner. Look-alike oil foam elements are very often of a lesser quality. They merely increase the chance of a problem, some substantially more seriously than others. Wash the element using common household liquid detergent and water. Do not use gasoline to clean the element. Rinse the element until the water flows clean and all the soap has been removed. Next, wrap the element in a rag or paper towel and squeeze dry. Now, saturate the element with oil using the same oil selected for the crankcase. Squeeze out the excess oil. By doing this, the oil is also distributed throughout the element. Incidentally, in speaking with large fleet users of equipment, many have told us that they maintain a backup supply of ready-to-go serviced elements. This allows a quick exchange, even on a daily basis, or even more often if needed. This also serves as a convenience for easier adherence to a preventative maintenance system. When reassembling the air cleaner, the element lip must extend over the edge of the air cleaner body. This lip forms a protective seal between the upper and lower bodies when correctly assembled. And the air cleaner assembly must be assembled tightly on the carburetor, maintaining an effective seal so that airborne grit can't gain entry through bypassing the air cleaner assembly. When used with an oil foam pre-cleaner sleeve, service the paper cartridge every 100 hours. If not standard, that is with a pre-cleaner sleeve, service the cartridge every 25 hours. Daily service may be required under extreme dusty conditions. Remove the cartridge and clean first by tapping gently on a hard, flat surface to remove dirt buildup. If it's extremely dirty, replace the cartridge with a factory original replacement part. Do not oil the cartridge. Do not use pressurized air to clean the cartridge, for the paper could tear. Servicing the pre-cleaner sleeve is identical to the procedures already detailed for servicing the oil foam element. Service every 25 hours. Abrasive grit gaining entry into the engine causes destructive premature wear, and as an equipment operator, you experience the effects of extreme wear through noticing a power and performance drop, as well as excessive oil consumption and smoking. Let's take a look at what else happens. Shown here are two oil foam elements. The one on the left has been maintained and properly oiled. Notice its clean and even color. The element on the right represents one which has not received proper maintenance, probably washed but not re-oiled. Note the dark streaking caused by dirt penetrating the full thickness of the foam. Once through the element, the grit is now free to travel unchallenged deeper into the engine. Next, the grit passes through the carburetor, heading towards the cylinder intake valve port. The intake valve face and seat will sustain a unique wear characteristic, as shown here. Note the width of the valve seat, with the widest or the most worn area nearest the cylinder bore. Eventually, compression is affected. The engine loses power and fails to perform acceptably. Drawn further into the engine, the grit causes extreme cylinder bore wear. Note the worn ridge at the top of the ring travel and the absence of cylinder crosshatch patterns. An excessively worn bore results in excessive oil consumption and smoking. The rings will also be ruined. The result is a poor seal between the rings and the walls of the cylinder bore. Another view of a worn ring, this time the oil ring. All internal moving parts, such as the crankshaft and bearing surfaces, sustain wear. Critical working tolerances change, producing erratic performance. Wear can be deceiving, even to a trained technician. Here, let's show you what we mean. To the eye, the bearing in this crankcase cover looks okay, but when using the go, no-go reject gauge, we see that that bearing is excessively worn. What this means is that this cover is not acceptable for continued use. Damage sustained because of premature wear is usually widespread and beyond economical repair, usually requiring a short block or replacement engine to repower the equipment. Normal wear, when running an engine for many hours, properly maintained, will not result in the kind of wear we have just seen. As long as we're on the subject of premature wear, cleaning spark plugs through a blasting method is dangerous to your engine's health. Many truly conscientious maintenance specialists really believe that blast cleaning will salvage plugs, cut repair costs, and improve engine performance. Actually, blasting can leave highly abrasive grit within the plug. When the plug fires, grit bombards internal moving parts, causing extreme wear and early engine replacement. An air-cooled engine requires unobstructed air circulation for cooling. Air is drawn into the blower housing by the rotating flywheel and is strategically directed throughout the cylinder fin area. Any obstruction to this cooling process will result in excessive temperatures well beyond the acceptable operating range of the engine. Even a partial obstruction is sufficient to raise operating temperatures above acceptable limits. Often, dirt, grass clippings, leaves, tar, mud, etc., clog the cooling fins, interrupting the necessary flow of cooling air. Overheating results. Operating an engine in a too confined environment will also cause a like problem. Engine overheating can have several damaging effects on an engine. Abnormally high engine temperatures cause the fuel to boil. Air bubbles and gas vapors form in the fuel system, producing hard starting or stalling out shortly after the engine has started running. Valve seats can loosen, and hot spots develop in the cylinder bore, as shown here. In some extreme instances, operating temperatures become so excessive that the crankcase oil becomes cooked, as shown here. The oil loses its ability to effectively lubricate. It thickens and hardens. Monthly, or every 100 to 150 hours, remove the blower housing and clean out the cylinder fin area. Generally, most engine failures can be avoided. By adopting a preventative maintenance system, an engine will generally outlive the service period which most equipment owners have come to expect. A successful maintenance system means having knowledgeable personnel performing field-proven preventative maintenance. We believe the total maintenance system ought to include 1, designating one person responsible for all engine maintenance. The advantage of this idea is that he becomes the specialist in knowing how to perform the preventive maintenance procedures. He becomes familiar with local dealers for parts, and he learns efficient troubleshooting. Don't let your engines become orphans. 2, establishing a routine calendar maintenance schedule and strictly adhering to it. No excuses. More about the schedule shortly. 3, maintaining a log or some tracking or coding system to ensure continuity of maintenance for each of your engines. A sample log is shown here for tracking critical oil changes and servicing air cleaners. Realizing that it is impractical to keep track of the hours an engine works, and since some equipment will naturally be asked to run for longer periods of time, we believe a calendar preventative maintenance system is the most practical for you to implement. A calendar approach corrects the situation where an equipment operator has little or no idea how many hours he has on his equipment. Since engines don't have odometers like automobiles, or hour meters normally, the next possible method of knowing when to perform service is using a calendar system. A preventative maintenance system using a calendar basis would look something like this. Daily, or every 8 hours, check oil level and fill if necessary. Every third day, or every 25 hours, let's say every Monday and Thursday morning, service the oil foam air cleaner element or pre-cleaner sleeve if it is equipped with one. Better yet, just install one of the ready-to-go serviced air cleaners. If equipped with a paper cartridge only, that is without a pre-cleaner sleeve, service or replace the filter. Weekly, or every 50 hours, let's say every Monday morning, change oil when warm. Refill with a high-quality oil matching viscosity to season. Monthly, or every 100 hours, let's say the first Monday morning of each month, service or replace the dual-element paper cartridge if it is foam pre-cleaner equipped. Remove the cylinder head and clean out the combustion chamber deposits. Remove the blower housing. Clean out debris from the cylinder fin areas. It may be necessary for you to perform these maintenance procedures more often, particularly on your more regularly used equipment. For less frequently used equipment, a little common sense is required in adapting a suitable maintenance system for these engines. Now that you've seen our calendar preventative maintenance system, the ball is now in your court. Nothing very complicated, but a few common sense ideas requiring a positive state of mind on your part to make the system succeed. The better the system, the longer the life. You can't afford not to maintain your equipment. Depending upon the type of the equipment and your geographical location, there are times when you'll find it necessary to store equipment from one season to another. Shown here are the necessary precautions you should take. Drain the fuel system completely, or fill the tank completely, treating fuel with stable. Run the engine until it's out of fuel if draining the fuel system. While warm, drain the oil. Refill with fresh oil, matching viscosity to the season when the engine will next be run. Remove the spark plug. Pour 1/2 ounce of oil into the cylinder bore. Crank slowly to distribute the oil. Replace the spark plug. Gap the plug to 30 thousandths of an inch. Store in a clean, dry area. The use of plastic to cover equipment during high periods of humidity can cause condensation to form, and breaker points to oxidize. As a further sign of our making sure you're getting the most of your Briggs & Stratton engines, we offer local engine seminars throughout the country. These hands-on technical seminars are designed with the engine-powered equipment user in mind. He who performs his own engine repairs and who desires to learn more about good techniques for keeping the equipment on the job. And better yet, these seminars are generally free. You can't lose. We will show you how to take care of your engines. You concentrate on other important business matters. Just contact us for more details. In many instances, engines are selected solely on the basis of price and not necessarily based on their expected duty cycle or the environment in which they will operate or the rugged demands of the application, which very often require industrial commercial features. While price is certainly an important consideration, the true cost of considering price only could perhaps be best measured in terms of equipment downtime. Complementing the calendar preventative maintenance system are Briggs & Stratton IC series engines, equipped with standard long-life engine features. These features, too, contribute to keeping your equipment going. Let's take a look at these standard features and their benefits for your demanding applications. Cast iron sleeve bore for better wear and extended cylinder life. The sleeve is integrally cast with the cylinder for years of trouble-free service. Magnetron electronic ignition system, completely maintenance-free, no moving parts, eliminates the need for adjustments. Assures quicker, more dependable starts with 5 times longer spark duration than competitive systems. Made for the life of the engine, it can also be retrofitted to most Briggs & Stratton engines equipped with breaker points. No more ignition tune-ups. The system is that good that we warranty it for 5 years. Dual-element industrial-type air cleaner, pleated automotive-type paper cartridge surrounded by foam pre-cleaner sleeve. Only the cleanest air gets through to the carburetor. Means longer service intervals, extended engine life. Sealed throttle shafts provide extra protection in keeping dirt out of the engine. DU and ball bearings, heavy-duty DU and ball bearings are replaceable to keep downtime to a minimum. DU bearings are high-performance, self-lubricating, combining the best 2 bearing materials, bronze, and a Teflon-like material with a steel backing. Cobalite exhaust valve and seat with valve rotator and replaceable centered iron valve guide for better wear and heat resistance. Valve rotator rotates the valve on each lift, keeping combustion deposits from lodging between the valve and seat. Shown here is a valve rotator at work. Note the red mark on the exhaust valve rotating towards the red mark on the cylinder, while the green marks on the intake valve side remain aligned. The valve rotator, combined with a Cobalite valve and seat, provides up to 5 times longer valve life than other materials. Super low-tone mufflers are standard for quieter running and longer life. They reduce exhaust sound by as much as 50%. They are aluminized construction for maximum protection against rust and corrosion. These mufflers have provisions to receive spark arrestor and deflector assemblies. And 2+5 warranty is standard on all IC series engines. That is, 2 years on the engine and 5 years on the magnetron ignition system. And as optional equipment, selected engine models offer quick emergency backup starting. Various IC accessories add to the engine's service life, such as chromed debris and muffler guards. Available for selected engine models, Oil Guard, the low oil shutoff system, eliminates engine failures due to insufficient amount of oil, automatically stops the engine at 70% oil capacity with added visual warning. Designed for stationary or moving applications, it lets you run continuously up to 15 degrees and intermittently up to 30 degrees angle of operation in all 4 positions, surpassing competitive systems. Eternal combustion engines. You can make it happen. Just implement the proven calendar engine maintenance systems and specify Briggs & Stratton industrial commercial engines as the power in your power equipment. As we've been telling people, you'll be eternally grateful.